Yes, we'll discuss general organic chemistry, general organic chemistry, GOC, right? Here, what we discuss? We discuss mainly those electronic effects which affect the energy of the molecule or the stability of the molecule. Here those electronic effects, right? Those electronic effects we keep in two parts: permanent effect and temporary effect, right? We take here permanent effect and temporary effect. Under this permanent effect, we discuss inductive effect, we discuss resonance and resonance effect, we also see that one mesomeric effect. We will discuss in detail mesomeric effect, and the last one we discuss here, the hyperconjugation. Right. These are the things we discuss under permanent effect. And under this temporary, we take here the mainly two factors. One, electromeric effect, and the other one, temporary one. Electromeric one and inductomeric one. Inductomeric effects. Yes. Most of our discussion will come under this one, right? We start our further discussion with inductive effect, right? Let's discuss inductive effect, okay? Inductive effect. What is this inductive effect? As we discussed, this is the permanent effect. But what is this inductive effect? The effect what arises due to the electronic displacement in a row along the C single bond due to the presence of an atom or due to the presence of any functional group other than hydrogen. Let's summarize this part. Inductive effect, you can say that it is electronic displacement, right? Electronic displacement a kind of electronic displacement. All electronic displacement, you can't say inductive effect. Electronic displacement that also in a row along C single bond. Why? Due to due to the presence of an atom or group other than hydrogen. Other than hydrogen. Yes. This is electronic displacement. Electronic displacement that also in a row along C sigma bond due to the presence of an atom or group other than hydrogen. Here you see, I take here one example. I take here one example of HCl. We know in this bond, one electron is contributed by this hydrogen, other electron is contributed by this chlorine. Both contribute one electron. But because of the greater electronegativity of this chlorine, chlorine pulls this bonded pair of electrons towards itself and cause uneven distribution, cause greater accumulation of electron near to this one, and because of that this kind of polarity arises. You see there is a partial negative, there is a partial positive. This is also electronic displacement. There the electrons move, this pair of electron moves towards this chlorine. We say this one simple electronegativity difference effect. Right? Now, I take here the wider perspective. There, let's take here another example. C, and I take here now there the Cl. These hydrogens are connected to, these carbon atoms are connected to hydrogen atoms. Right? Now, what I say that there also the same thing is observed, right? This chlorine pulls bonded pair of electrons toward itself, and now there is partial negative. And because of this polarity, because of this kind of electronic displacement, their partial positive charge arises. Now, in order to nullify this deficiency, what arises here, electrons are rushing from along all the bonds to nullify this one. And so, electrons will move there. This is the effect of the presence of Cl. Now, along this bond also, electronic displacement can be observed. And because of this kind of displacement, for that, indirectly Cl is responsible, directly this one is responsible. So there, this kind of polarity is. Now, this at this deficient center, again, these atoms along these bonds, process starts to nullify this deficiency. This effect reaches here now. This continues. Now this kind of effect arises there. Now we can say that the process what started here with the Cl, that continues. It induces this one, that induces this one for this kind of electronic displacement what was initiated by chlorine. This is inductive effect. Here, this due to this electronic displacement, what electrostatic, this is kind of electrostatic effect what arises, that is inductive. Inductive effect is a kind of electrostatic effect. This one is permanent effect. Permanent effect means you understand that which is the integral part of this molecule, and so which arises due to one of the integral atom present in the molecule. Yes. In this context, you might have developed one different perception. You will think that for all this kind of electronic displacement, it is the chlorine what is responsible. That is true, it's the chlorine. But it's not only chlorine. Chlorine is pulling electrons towards itself because of its greater electronegativity. And that is successful because even the carbon is supporting this kind of electronic displacement. You will say this chlorine is having electron withdrawing nature, at the same time the carbon is having electron releasing nature. So don't think here that this is happening because of only chlorine. Chlorine is pulling, and so this one is acting as electron withdrawing. And here the carbon is releasing, so this part you will say that electron releasing. So in this discussion we can say that wherever this kind of electronic displacement is observed, there will be two parts. One electron withdrawing, other one electron releasing. In those electron withdrawing groups are categorized as per the nature -I groups, which cause electron pulling inductive effect, -I group. Electron withdrawing groups, -I groups. And other part you say the +I groups, +I. So the same thing you have to see from the different angle. And -I groups and +I groups. Some of the groups are -I, some of the groups are +I. Then you will say that's which are -I, and how to know? Yes. Here one thing you understand what I have written in the definition itself. That electronic displacement in a row along C single bond due to the presence of an atom or group other than hydrogen. Yes, this is the deciding factor. This reference line is hydrogen. So all those atoms or groups which withdraw electrons better or more effectively than hydrogen, those are -I groups. And all those atoms or groups which releases electrons better than hydrogen, those are +I groups. So whether the group is -I or +I, that depends on that how good that is taking withdrawing electrons in comparison to hydrogen. Better than hydrogen, -I, poor than hydrogen, +I. Okay. Now, it's not final that there are many groups which are -I. No. All those minus groups are not having the similar strength as per the nature. Those groups vary in their strength, and that is very important here what we need to learn. At this moment, we will not discuss much here. -I groups will not discuss much. That why -I? Later you will learn even that one, that why -I. But at this moment, in the beginning of the GOC, it may be difficult to make you realize that why -I. But later certainly you will understand this part also, right? So understand here the -I groups I write here in the order NR3+, Sr2 plus NO2. Notice this. In the beginning, you observed that it is just like the electronegativity group, but it is not electronegativity. Electronegativity is one of the factors. I effect, inductive effect is much wider than the electronegativity. And electronegativity is just one component, because inductive effect depends on electronegativity, electropositivity, their polarizability, polarity, size, bond angle, so many things. Right? Electronegativity is just one factor, and that's why the most electronegative fluorine is not the strongest Manessai. NR3 plus, Sr2 plus, NO2, Cn, COOH. Now you will get here the fluorine, chlorine, bromine, iodine. You will get here OAR. AR is the aryl group, substituted phenyl group. C double bond OR, keto group. OH, C triple bond CH. Here now I write NH2 amino group. Then I write pH, this phenyl group. Okay, we write also pH. Then there the CH double bond CH2. That is in decreasing order, right? NR3 plus, Sr2 plus, NO2, Cn, COH, F, Cl, Br, I, OAR, COR, OH, C triple bond CH, NH2, pH, phenyl group, CH double bond CH2. These are Manessai groups in this order, right? In this order. Here, you can take the plus I groups, right? And you know, it's very easy to remember. This is also very important, that which one is having minus I and which one is having plus I. Most of the works get done with this understanding only. Better questions involve relative strength. So it's very easy to remember which are having the plus I groups here, except few like O minus, and there the CO, O minus, C double bond O and O minus. These two are exceptional, right? I don't say exceptional, but these are having plus I. O minus is the strongest one. Very important. OH is minus I. O minus is plus I. And that also is strongest plus I. COOH minus I. COO minus plus I. Yes. Net electron releasing in nature form. Then there are CH3, and there the CS3. I say this one tertiary alkyl group, right? You take here this one tertiary alkyl group. And next one is CH3 and CS3. This one is secondary alkyl group, right? And CH2CS3 primary alkyl group. Here only you can write even there the CH3, and you write one more. Here only we will close this discussion with this one, D, deuterium. And reference line, you know, reference line is hydrogen. Reference line is hydrogen. So D has better electron releasing tendency in comparison to hydrogen. This is the plus I. Although this one in the decreasing order, this has very less but better than hydrogen. Right? Alkyl groups have plus I. Alkyl groups have plus I. Here now, this order, certainly you have to, it must be there on your tongue. Tuck, 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 you have to answer. Huh? Yes, you should know this order. And if you read this order there the 3-4 times, automatically your mind will start processing and will start extracting some of the things, and you will be able to compare even for those functional groups, those substances which are not mentioned here. And that is very important one. Here also, you will start predicting few things. I take here that kind of comparison. You see this with that, what groups we have noted down. And now I am telling you here that we will compare some of the groups which are not there. I take here comparison. Although I have given in order, but then also it is required. For example, I want here, there the OH and there the SH. Minus I comparison is there, right? Minus I comparison. OH and SH. Yes, which one is more minus I? Already you have seen. In that order, fluorine, chlorine, bromine, iodine, there the electronegativity decreases and so minus I decreases. Minus I depends largely on electronegativity, and so as electronegativity decreases, minus I electron withdrawing effect of the group decreases. Same trend is followed here, and so here the OH is better than the SH. Correct? Minus I. Exactly same thing we observe in the case of plus I. Plus I, moving down, electron withdrawing capacity decreases, but electron releasing tendency increases. So, plus I increases. And that's why this interesting comparison you see, this one is C, CH3, CH3, CH3. And there is SI, CH3, CH3, CH3. Comparison is there of the plus I, as I discussed. There as moving down the group, electropositivity increases, so electron releasing tendency increases. Which one is stronger plus I? Certainly, silicon. This trimethylsilane is the better plus I. This has more plus I. Okay. Take here some more comparison. There, I take CH double bond NH. In there, the N double bond CH2 minus I. This compound. No doubt. I have not given both. Actually, I have not given anyone in that table. But you can compare. Because you know that it all depends on the atom which one is withdrawing. Here it is the carbon. This is sp2 hybridized, and that sp2 hybridized carbon is pulling here. It's the nitrogen, and nitrogen is better one. So this is the better one. Right? If there we have CH double bond NH, and there the CH double bond O minus I don't think that you will take any time to decide, because that part is constant, and oxygen more electronegative from the back side will pull electrons better, and so this will be having more minus I. Correct. Not only that one. You can even compare there the N double bond O and there the NO2. This is the right way to express here the NO2. Dative bond we write. But in the place of dative bond you can write here the plus and O minus. So that you will understand that what is the extra effect here in this NO2. Nitrogen is not having lone pair as it is there. Nitrogen is having, in addition to that, positive charge. And so, which one is better minus I? Certainly NO2 is the better minus I. Right? Here you see, I write here the CH double bond CH2 anyway. This thing as it is I have asked, but again I would like to mention here there is a CH double bond CH2 and C triple bond CH. Comparison is there of minus I only. Which one is the better minus I? Which one is the better minus I? And why? This carbon atom is sp2 hybridized and this carbon atom is sp hybridized, and you know that in this case 50% s character, more s character, so more electronegative, more electron pulling. At the same time this one is relatively less, so this has more minus I, right? Yes, that only is the reason. You will say very confidently, which one is the better minus I? Yes, there is sp2, there is sp. So this is more minus I in comparison to this one, right? You can really compare very well, right? Here, one very interesting group is there, that is C triple bond CH and there the NH2. Yes, minus I comparison. You must remember this, no? No doubt nitrogen is more electronegative than the carbon, that we know. But nitrogen is less electronegative overall in comparison to the sp hybridized carbon. sp hybridized, you know this one as I discussed here. With increase in S character, their electronegativity increases, electron pulling strength increases, and that becomes more effective than that one. Remember this, it has good application in the coming days. So this C triple bond CH has more minus I in comparison to this NH2. I hope you are very clear, right? Okay. Now I discuss one more important. There, the branched regarding alkyl groups. One thing you remember, that branching of the chain, because this is a short range effect, it doesn't work for long distance, because as you are moving away from the source, that keeps on decreasing significantly. This is short range effect. Maximum it works more there up to the 4th carbon atom. After that it has no effect. Here when I say branching, so as the carbon atoms keep on increasing, the effect of every carbon atom keep on decreasing. So if that methyl group is closer, or that kind of branched methyl, ethyl or whatsoever, the effect which arises, that will be more. And that's why you understand that branching increases plus I. Let's take here one example, you will understand it better. Here CH2CH2 CH2CH3, there CH2 CHCH3 CH3 CCH3 CH2 CH3, and there the CH3 CH3 CH3. These are the groups. Let's take here, this is 1, this one 2, this one 3, this one 4. Yes. Okay. Now you see this. There is methyl group, so this is near to this one. We have to experience everything on this center, free valence center. So this effect arises better here. There, this one is very slow, this one is secondary also, and this one is still secondary. This methyl group, this methyl group, this methyl group, certainly this effect is more. So what's the net answer? Which has the decreasing plus I? Which has the maximum plus I? Certainly fourth one. Maximum plus I. After that, second one. After that, third one. Then there the second one. Then there the first one. Yes. This is order. Branching increases plus I. I take you one very interesting example right now, because I mentioned there the deuterium. I mentioned there deuterium, so that is also one of the very good example. You see, I write here the CH3 and there the CD3, which has more plus I. As I discussed, D has more electron, more D is more electron releasing in comparison to hydrogen, so overall CD3 has more plus I. Yes, that has more plus I. You can compare based on this also. There the H, there the D, and there the T plus I. You can compare. Yes, you are correct. There the tritium, the heaviest isotope, will have the more plus I than the D, and D is having already more than the H. Yes. So this is the comparison of plus I. In that thing, you have extended based on the understanding what you have developed from that given order. Although I had given very few, but if you read there more and more again and again, you will develop this kind of perception, and then you can extrapolate that one, and you can compare all these things. I can discuss here one of the very interesting example, very interesting and very top level example, right? You see this one, I write here one molecule. This is very good example. Please you see this. I have to write here the direction of that electronic displacement. Right. Direction of that electronic displacement I have to write. And now, for this you have to understand a lot. I just give some introduction. You see, this is the case. But before this, you have to think, you have to recall this trend CH2CH3, CH double bond CH2, and there the C triple bond CH. You know that this one is SP, this one is SP2, this one is SP3. SP3 109 degree 28 minute. SP2 120 degree, 180 degree. There this S character has some relation with this bond angle. As the bond angle increases, S character increases, so electronegativity increases. So let's summarize here as bond angle increases, right? There S character increases. and so the electronegativity increases. Here how we interpret, how we relate all these things. What is the bond angle here? Bond angle here. Bond angle is 60 degree. Okay, inside bond angle is 60 degree. This one is sp3 hybridized. sp3 hybridized and bond angle is 60 degree. So whatever compulsion or restriction is kept on these two bonds of the ring will be compensated here. What is the standard bond angle of sp3? 109 degree 28 minute. 109 degree 28. This is the standard bond angle. And as the other side two bonds are kept at the lesser bond angle, so these two will be at the larger angle. Certainly this x is greater than 109 degree 28 minute. If this will be lesser and lesser, these two will be bigger and bigger, and character, S character will be redistributed there. Right? So certainly as this bond angle increases, so in these bonds there the S character increases. Understand this. Same thing if we analyze here in this case, this is cyclobutane. There also, this one is the 90 degree. So as this one is 90 degree, bigger than that one, so if I say this one is the Y, then the Y is lesser than the X. Because this one is bigger, so that will not expand bigger. That will expand relatively lesser. This is more compact, that is more opened. Here this is relatively less, so this one is less opened. Now this one, as you find here that X and Y, if you compare, you will find that X is greater than the Y. It means this angle is more. If this angle is more, so this will be having S character more. So in this bond, S character will be more here. This one is electron negative, and that will be pulling electrons towards itself. This is the direction. I hope you got it. Right? This kind of interesting thing you will keep on learning. These are the highly conceptual things. And that you develop based on the understanding of all the basic concepts. Hope you have enjoyed, and we'll keep on discussing. I just wind up this session here only. Thank you.